Hello everyone, this is Ayusha Jha. I am a faculty of chemistry and today I will discuss class 10th topic acid base. So let's start. So first thing that is anything which is sour in taste is must be an acid. So anything if you taste anything and it is sour in taste then it is must be an acid. Now you can't eat and taste anything to say that it is an acid or base because it may be harmful for your health. So now what will you do? So this problem is solved by indicator. So now what is indicator? Indicator. So indicator are substance or dye which changes its color on when acid or base is added to them. So we are writing here substance or dye changes color on adding acid or bases. We can say that indicator tell us whether a substance is acid or base. Okay, so indicators are two types normally. What are these types? First is natural indicators and second is synthetic. Natural indicators are those which are obtained by nature itself. We don't have to make it. First example, it is very famous and it is litmus. It is litmus. It is very well known example. Okay, so what is litmus and where it is obtained from? So litmus is a purple colored dye. What is litmus? It is a purple colored dye which is obtained from the lichen plant. Lichen plant. You can also call lichen or lichen anything. So actually it is a mixture of algae plus fungi. And this plant is belong to the division Thallophyta. Okay, so these are the basics. The litmus is where from it is obtained and what is its color. Now when the solution is when the litmus is neutral, when the litmus is neutral, it is purple in color. The litmus is neutral, it is purple in color. Okay, purple. Okay, now if we add a substance which is acid, then its purple color is convert into red when acid is added to this litmus. Okay, and it changes its color to blue when bases are added to them. Okay, so it is commonly found in purple solution, but for our convenience but for our convenience nowadays it is also found in red and blue strips. So here it is a little, you can say, formula to remember it, or you can say it is A plus B. What is this? You can say when acid convert blue litmus to the red color and the bases convert red litmus in the blue color. Most people mostly confuse in that acid convert in which color, but here you can easily say that acid convert blue litmus to the red and bases convert blue red litmus to the blue. So from here you can this topic is clear. Now we going to the second natural indicator, which is turmeric. which is turmeric. Everybody know that turmeric is yellow color dye. It is a yellow color dye which is on adding base convert into the reddish yellow color, reddish brown color, red brown color. The common example we all know, when we eat food and by mistake it is split into our clothes, then it has a yellow stain. Now when we add some soap to it and rub it, it is and splash water on it, it convert into red brown. And after again rinsing with water, it again changing into yellow color. Okay, so this red brown color is it is because turmeric is the indicator, and on treating with base is converted to red brown color, and it remain colorless. It remains in its own color when we add base acid to it. So now next natural indicator are some petals of flowers called petunia and other. And one is red cabbage. Red cabbage extract, which is obtained from the red cabbage itself. So red cabbage is a litmus. It is the indicator which, on adding base, convert into green color and remain in red in their own color in acid and green in bases. So here we talked about natural indicator. Now we will talk about synthetic indicator. So what are synthetic indicators? Synthetic indicators are those which are prepared by artificially by man. So synthetic indicator. So what are synthetic indicators? The common example is methyl orange. By the name it is clear that it will be orange in color. And second is phenolphthalein, which is colorless. Now these methyl orange, on treating with base, convert into yellow color, and when adding with acid, it will convert into red color. Phenolphthalein, on adding acid, will remain colorless, and on adding base, it is convert into pink color. Here is one more artificial or synthetic indicator, is universal indicator. Universal indicator. All these indicators tell us whether a substance is acid or base, but these universal indicators tell us the exact value of pH, means the value of pH is 1, 2 or 3, like this. So here is the example. We all know the 7 color is pure. If we took a solution and if it convert into violet, indigo, blue, then the solution must be an basic solution. right? And if the solution convert into yellow, orange and red, then the solution must be an acidic solution. And if it convert into green color, yeah, or remain in green color, then it is a neutral solution. Now we will talk. Universal indicator is made up of thymol blue, bromothymol blue, methyl red, and phenolphthalein. So universal indicator is a mixture of so many of dyes. So when adding different kind of pH, it will convert into a different color. So it can tell us the exact value of pH. Okay. Now here we talked about indicator. Now we will talk about the exact definition of acid. So telling that any substance which is sour in taste, it is an acid, and anything which convert red litmus to the blue is not enough. So there is a scientist came with a concept named Arrhenius. A scientist came with his concept. According to him, any substance when adding with water, if give H plus ion in their aqueous solution, then it must be an acid. Any substance in their aqueous solution, if give only H plus as only positive charge, then it must be an acid. Okay. So and now these H plus is a bare proton. Why? And it is very unstable. And the reason behind it, actually we all know that the atomic number of hydrogen is 1. Okay. Now electronic configuration will be 1s1, and if one electron from its valence shell will be taken by anyone else, then it will convert into H plus. There is no proton here, only proton, and no electron here, no electron, only proton. So that's why it is very unstable. And to get stability, it reacts with this H plus react with H2O and convert into H3O plus, which is also called hydronium ion. Hydronium ion. Okay. Now, if in chemistry if we write H plus is equals to H3O plus, the means of both will be same. There are and more concept, we will discuss it later, but now we will read about the type of acid. Acids are of two types. Strong acid inorganic acid, and organic acid. These acids also called mineral acid. Why? First we will discuss about organic acid. So organic acid are substances which are obtained by the nature, and nature is thing obtained by the nature and natural. It is edible, and these are weak acid. These example of it are acetic acid, citric acid found in citrus fruits, tartric acid found in termine, oxalic acid found in tomato, and so on. So why these acids are weak acid? Because if we took 100 molecule of acetic acid, the formula of acetic acid is this CH3CW. Now if we took 100 molecules of it and we want to ionize it, then only 5 of them will be ionized in CH3CW minus and H plus. Only 5 ions in these 100 molecules will be ionized, and 95 molecules remain as molecules. So when dissolving in aqueous solution, they give a very less amount of H plus ion. That's why these are called weak acid. Now we will talk about inorganic acid or mineral acid. Acid which are obtained from the earth crust and inorganic substances are called inorganic acid. So these are mostly corrosive and it is not edible, mostly not edible. Obviously if it is corrosive, then how can you eat it? And mostly not edible, and these are weak acid. Sorry, these are strong acid. The reason behind it that these are strong acid is when you took 100 molecules of strong acid, which are HCl, H2SO4, HNO3. First thing is these all three are also called bench acid. Bench acid. Why? Because mostly on the lab you find it on bench. So also called bench acid. So if you took 100 molecules of HCl molecule, then the 100 of them will be ionized and give completely dissociate and give 100% of H plus ion. So they give H plus ion in large amount. So that's why these are called strong acid. Okay. So here we talked about strong acid and weak acid. Here is a one exception, which is a H2CO3, which is carbonic acid. It is a mineral acid, but it is a weak acid. Why? Because on dissociated, it not completely ionized and only 5% in 100 molecules, only 5 will be ionized. So that's why it is a weak acid. So it should be rememberable and it is an exception. So now we will talk about the third definition, which is pH. If any substance has a pH value less than 7, then it must be an acid. So now what is the meaning of pH? And what is the why it should be less than 7 to be an acid? So in 1909, a scientist named Sorensen came. So people before that calculating H plus ion in their aqueous solution in the very small numbers like 10 to the power minus 7. So these are very small numbers. So he came and gave power to this number. So here P means potence or power of power, and it is with H, so it may power of hydrogen. So here you can easily say that the pH is power of hydrogen. So these are very small number. Sorensen came and gave power to these number. So we can easily calculate the value of substance in form of acid or base. So he did a mathematical calculation, and according to his mathematical calculation, which is like this, pH is equal to minus log 10 to the H plus ion. So according to him, the definition of pH will be the pH is the concentration of hydrogen ion. Negative log pH is the negative log of the hydrogen ion concentration. अगर हाइड्रोजन आयन की कंसंट्रेशन का नेगेटिव लॉग लेंगे तो वो पीएच के इक्वल होगा. ओके, so you can easily say whether a substance has a pH value less than 7, then it must be an acid, and if more than 7, then it will be a base. So these are the normal properties. By seeing you can say that whether a substance is acid or base. Now coming forward, we will see the properties of acid. Properties of acid. Properties of acid. Acid, on adding water, give ions in so many quantity, and conduct electricity. And the solution which allow electricity to pass into them are called electrolyte. So you can say acids are also electrolytes. Okay. The second properties of acid are acid when react with metal, they give salt and hydrogen. Anytime you took anything, metal plus acid will always give salt and H2 gas. Okay. How will you check that it is a H2 gas? When you took a burning candle burning candle to this, it will do a pop sound. And we all know that the only hydrogen gas give pop sound on adding fire to that. Okay. The third property is metals on metal carbonates or hydrogen carbonate, metal hydrogen carbonate on adding acid give salt, water and carbon dioxide. How? You can see here by this equation, which is, if you took sodium carbonate plus H2SO4, you will get, or HCl, you will get NaCl plus H2O plus CO2. Same reaction you get with the hydrogen carbonates. These are NaCl plus H2O. So metal carbonates and metal hydrogen carbonates on reacting with acid give salt, water and carbon dioxide. How will you test this? When you add lime water to it, if you took lime water, which is this, lime water to carbon dioxide, carbon dioxide will convert lime water to milky, which is, it form calcium carbonate, which is the white PP. So they convert lime water milky. There's a milky. Now, if you add excess of carbon dioxide to this, the solution will again form colorless. Like if you add CaCO3 and excess of CO2 to this, they form calcium hydrogen carbonate, which is again clear solution. And last and final property of acids are acid on adding base give salt and water. It is also called neutralization. Neutralization. Which is, and the reaction is HCl on adding NaOH give NaCl and H2. You all know that it is a common salt and also water. So here we talk about everything about acid. Thank you for this section.